we'll hear about our technical processes, market potential, differentiators, and where we are on our roadmap. We'll be hearing from a few different members of our team who are each experts in their fields. Please feel free to submit any questions you have to the chat, and we will address as many as time allows at the end. And a recording of today's webinar will be available to anyone who registered. So now I'd like to turn it over to our CEO, Mendel Bassman.
Thank you, Shoshana. It would be easier if everyone mutes so you don't hear me double through someone else's speaker. I thank everyone for joining us today in this very important conversation. We are, as Shoshana had mentioned, coming off Earth Day, and all of us have a passion to make the world a cleaner place, be more environmentally conscious. But what makes things unique at Smart Tire Recycling is that we're taking that passion and we're converting it into something which is actionable. We have a solution that works and that can make a major impact. My family has been in the scrap metal business for over 2 decades. And I was always looking for something in the environmental sphere, an environmental problem that I can take and turn it into what's referred to as a circular economy, making something environmentally friendly that is also profitable, making recycling profitable. In my opinion, the reason why currently the scrap tire problem has not been solved, and globally, close to 85% of scrap tires are still stockpiled in the ground, is because the current approaches to recycling tires are not profitable. With our patented technology that our team has developed, we can make scrap tire recycling profitable. We can bring close to $3 to $4 of revenue per scrap tire. And this will make a major impact in solving the problem of the scrap tires and can potentially be a very profitable investment for the investment community. Today, you will hear about an exciting opportunity to help us take our solution to a major global problem to the next level. Thank you very much.
Thank you, Mendel. Now I'd like to introduce our CTO and board member, Dr. Schulte. Dr. Schulte holds a BS in chemical engineering, a PhD in chemistry from the University of Florida, and an MBA from the MIT Sloan School of Management. She started her career as a chemical engineer in the tire manufacturing industry and has successfully led commercialization projects in nanotechnology. Over the last 15 years, she led the commercialization of several product platforms focusing on product development, market research, funding, and customer-supplier relations. Dr. Schulte will be discussing the overall marketplace and explaining why she believes smart tire recycling will be very successful in the industry.
Thank you, Shoshana, and hello, everyone. More than 1 billion tires are discarded globally every year, raising environmental concerns about their end-of-life recycling or disposal. In the United States, 10 tires are discarded every second. Majority of these tires are burned or stockpiled, creating emissions that are worse Majority of these tires are burned or stockpiled, creating emissions that are worse than coal. Tires do not decompose. When tires pile up in landfills or junkyards, they can release chemicals into the air, ground, and water that alter the ecosystem. Just sitting in the sun, a waste tire releases methane gas into the air. In the United States, almost half of the scrap tires are used as tire-derived fuel. 26% of them are used as ground rubber, for example, in playground fields, 7% in civil engineering, for example, as a material additive to asphalt, and 11% are disposed. Globally, 85% of tires are still stockpiled. And these are low revenue markets. For example, the global tire-derived fuel market is around only $350 million. Carbon black, one of the products obtained from scrap tires through smart tire technology, is currently a $15 billion market, and it's projected to be $25 billion by 2024. 70% of carbon black is used in tire manufacturing, 21% as rubber parts in manufacturing, and 9% of carbon black is used as pigments for plastics and inks. Carbon black is produced by combustion of petroleum products, such as oil or natural gas. This process is highly polluting due to carbon dioxide emissions, ranging between 35 and 40 million tons. Smart tire recycling technology enables the recovery of both energy and material from waste tires, yielding valuable gas, liquid, and solid fractions. The solid fraction is known as recovered carbon black within the industry. And this offers both environmental and economic benefits over the regular produced carbon black. The use of recovered carbon black alone can reduce the size of carbon footprint by 80%, which is why many large tire manufacturers are trying to use significantly more recovered carbon black. Tire manufacturers have set specific targets to incorporate recycled materials, such as recovered carbon black, following the principles of sustainability and the circular economy. Estimated current recovered carbon black demand in the United States is 280 kilotons per year, which is 18% of the total demand. And only 5% of this demand is covered currently, and companies are paying a premium for recovered carbon black. The market is expected to grow at a compound annual growth rate of 11.7%. The growing demand for sustainable raw materials is a major driving factor for this market growth. Thank you.
Thank you, Dr. Schulte. I would now like to introduce you to Dr. Robert Enoch, who is the Covestro Professor of Chemical and Petroleum Engineering at the University of Pittsburgh, an honor that reflects his expertise in polymer-related technology. Dr. Enoch won the United States President's Green Chemistry Award for the design of new environmentally benign chemicals. He has received over $11 million in funding from the Department of Energy, National Science Foundation, the American Chemical Society, and chemical and petroleum industry. The University of Pittsburgh is one of the top-ranked universities in the Northeast and is on the list of the top 100 universities. It is also ranked in the top 5% by the U.S. World News and World Report. We are excited to be able to use a laboratory that Dr. Enoch has built over the last 40 years at the University of Pittsburgh through our joint venture. Dr. Enoch.
Thank you, Shoshana. I'm really excited to be a part of this project. I've been at the University of Pittsburgh as an active researcher and teacher since 1976. I've done a lot of work with high pressure and high temperature systems for petroleum and chemical engineering applications. I've actually worked with 40 different companies and industry organizations as a consultant. And in my classes, I teach the class on how to put together a complete chemical plant and how to estimate its profitability. And I'm also currently teaching health and safety in chemical plants. So I'm really excited to bring all of that experience and knowledge to this project. So let me give you a real quick overview of smart tire recycling technology. And in this slide, you see that we're trying to address the three problems that Mendel referred to a little bit ago. First of all, we're trying to solve this billion tire per year problem that was just mentioned by trying to make the recycling profitable. Secondly, we want to provide an alternative to the current state-of-the-art pyrolysis method, which I'll describe in a minute. And finally, as we just heard, we're going to provide a new way of providing a carbon black resource instead of manufacturing it in the way that it's currently done. So if you take a look at the diagram at the bottom left, this is just a simple overview. It's a big picture look at how tires are currently recycled, and it's a method called pyrolysis. And if you've never heard of pyrolysis, the idea is very simple. You just heat up tires or pieces of tires to a very high temperature, and you hope that they break apart in a manner that you like. It requires a lot of heat. It's conducted at a very high temperature. There's no extra added ingredients such as air or water or other gases. It takes a long reaction time, and then you can produce carbon black particles and an oily solvent. On the right-hand side is a look of Smart Tire Recycling's process, which is really, really clever. I'm really excited to be a part of it. And this time, what's coming in? Well, we have tire crumbs. Crumbs means smaller pieces of tires, and that's going to enable us to make this process continuous. So that's the first thing I want to say, that instead of having a big batch reactor for pyrolysis, sort of an enormous pot where you throw the ingredients in and let them cook for a long time, we're trying to make a continuous reactor, which can be smaller, require less energy, a smaller footprint. It has all these wonderful advantages. We still require heat, but not as much heat. We still require a high temperature, but not as high of a temperature. And we're doing a few things differently that are really clever. We're going to introduce a little bit of air because air has oxygen in it. And we're going to have a partial oxidation of the tire materials. We're not going to oxidize all of it, but we're sort of going to use the oxidation reaction as a way to snip these tall, long molecules apart. So the heat and the oxidation can break down the molecules efficiently. We're also introducing water. What does that do? That allows us to transfer the heat more easily and more readily and more quickly to the tire materials. And then we also have the option of adding in another high pressure gas such as propane. Why do we do that? Because the propane can help to dissolve the oily solvent materials, and then we can lower the pressure of the propane to recover it. So we will be producing a carbon black product. This oily solvent will be recycling the water, recycling the propane. So we have a more elegant, lower temperature, faster, cleaner process for generating the carbon black and the oily solvent. So if you look at the next slide, in the next slide, this is a figure if you want a little bit of a better idea of what the process is like, sort of what comes in and what comes out. This diagram comes from the Smart Tire Recycling patent. And on the left, you'll see the tire crumbs and the air come in. They get pushed through a pump, sort of an extruder pump is one example. And then they go into that rectangular box that is the reactor. The water comes in to help heat things up. And then it comes out in very small particles or droplets. And then you can add propane, the green arrow. After that happens, so that's where all the action happens. That's where the breaking down of the tire into the carbon black and the oily solvent occurs. And then you have to sort things out. So you may want to go to a simple separation device that collects the solid carbon black first. That's the RCB. The R stands for recovered carbon black. And then you could take all the things in the fluid phase to the second separator, and you can cool down the system and the water will condense. It'll literally rain out. You can collect that water and reuse it. And then you could lower the pressure a little bit more, and the oily solvent materials will condense and rain out as a liquid, while the propane can be recycled and recovered. So this is a wonderful overview of the elegant process that STR has developed. In my final slide, I want to tell you about this really exciting joint venture that we have going on with Smart Tire Recycling. And it's to take a look specifically at taking that carbon black and making it contain less ash, removing the ash. Now, carbon black shouldn't surprise you. You want it to be really, really high content of carbon, but ash gets in there. And what is this ash? It's mostly silica. You could think of it as very fine sand particles. And then this compound, you may be unfamiliar with zinc sulfide. Now, why is that there? Well, when they make tires, they add zinc oxide to make the polymer cure more quickly. And they also add sulfur to make the polymer molecules cross-link or join together to make a massive, resilient, elastic polymer. When you go through the process that we just spoke about, you'll form a zinc sulfide. So the silica, which is put into the tire, sort of as a filler and to give it better mechanical properties, comes out as silica. And the zinc oxide and the sulfur form this compound that comes out as zinc sulfide. And there's also a host of other compounds. So in a typical run with the STR technology, you might have 12, 13, 11% ash, and there's a market for that. So the little pie diagram on the bottom left represents the recovered carbon black. And what are we trying to do? Right now, we have this project going on where the Pitt students, myself, and the Smart Tire Recycling scientists and engineers, we're working together in a collaboration to take that ash content down to 10%. And if you do that, not surprisingly, there's more applications and a bigger market. And then we can try to take it to 5% and down to 1%, where it's comparable to that virgin carbon black made by the other process. So what we're going to be doing is taking a look at several physical and chemical methods. And by a physical method, what I mean by that is a method where you're not adding extra ingredients, liquids or gases. You're just working with the carbon black using some careful and clever physical tricks to get the ash out of it. And then we could also use chemical methods. And that means that we would add some sort of a reagent at certain conditions to try to extract those ash particles. And that gives you a real quick summary of the wonderful collaboration that's going on between Smart Tire Recycling and the University of Pittsburgh.
Thank you, Dr. Enoch. I would now like to introduce a newer face to the Smart Tire Recycling team. Bruce Horn is the industry recognized and well-respected subject matter expert in the oil and gas industry with a specialty in demulsifiers and water clarifiers and innovation and application technology. Bruce has extensive knowledge and proven track record managing domestic and international projects for super majors in the world. He has managed multi-million-dollar projects from initiation to commercialization for Shell and BP in North America, NOCs in Latin America, ExxonMobil in Africa, Chevron and Aramco in the Middle East, and ConocoPhillips in Europe. He has many publications and has received awards for his work in this field. He presented his latest technical paper at the Society of Petroleum and Engineers SP International Symposium on Oilified Chemistry. Bruce has been very intrigued by Smart Tire Recycling's oil-based solvent and has signed a letter of intent to purchase all of the oil that we produce. Bruce.
Thank you. I'm going to preface my discussion real quick about the solvent by saying that just the fact that the tires are going to be recycled and not cause environmental impact is a huge economical and environmental plus to this whole project. And then with the carbon black recycling, it's another great impact of this project. What I'm going to talk about is the solvent that is produced as a byproduct, which most people weren't sure what to do with initially. But when me and a few colleagues have discussed it, we found that this solvent would be very useful in other industries, including oil and gas. When oil and gas is produced, some of these oils have paraffin deposition or deposits, which block off pipelines or wells and cause oil to not produce as easily. And most oils also have asphaltenes, which also plug up well production. This solvent has been seen to be able to clean and help disperse the paraffin and asphaltenes away from the perforations so that oil can be produced and sent to the refinery. In my line of specialization, the emulsification, heavier oils are mixed with water when they're produced out of the wells, and they need to remove the water so that it can be sent to the refinery as a clean product. To remove that water, chemicals are used, and it needs to be these chemicals need to be dispersed throughout the oil to get to the water droplets and remove them. This solvent cuts through the oil very nicely, even the heavier oils from Latin America and North America, and disperses the chemicals that agglomerate the water so it can come out quicker. So there's multiple uses for this solvent in just those two realms, but it can also be used to clean wells from the paraffin and asphaltenes for stimulation of more oil. It can be used as a pipeline cleaner and a tank cleaner for refinery storage and things of that nature. So all the great aspects of this project on the recycling of tires and carbon black recycling is a tremendous aspect right there. But as a byproduct, there's also industry need for this product, this byproduct, to be in the oil and gas and many other industries. So once again, it's environmentally helpful to the entire globe in these manners. Thank you.
Thank you, Bruce. I'm excited to introduce you to Adam Epstein, one of our early major investors and board members, to hear about what he found compelling about smart tire recycling and why he decided to invest. Adam began his career managing his own equity fund, specializing in biotechnology. He transitioned into consulting with startups during their initial capitalization and development. With his background in marketing and product analysis, Adam advises small businesses throughout the United States, and we're grateful to have him on board. Adam.
Thank you. Good morning, everyone. I'm Adam Epstein. I've known Mendel, our CEO, for a few years, and he approached me to be on his team to help build his idea as an investor and advisor. So in general, when I look at an investment, I take two tracks. Either one, an investment that I'm in and out with usually a 3-year max goal to cover my costs. However, the second type of investment is a long-term investment, which usually entails large costs. And because of that, there's higher risk. But if it's a good investment, that means there's also higher reward. And I saw this potential with Mendel and smart tire recycling. I want to mitigate my risk in an investment with a great product, but I don't want to be stuck with a nebulous idea. So I want to also see a great team to bring the theory into action. And this is what we see. We literally have the world experts in this industry with us. And we have great minds together. Mendel's really assembled an unbelievable team. And the problem that smart tire recycling is attacking, it's a real issue. It's not made up. Sometimes I've been approached by companies where they have to kind of create a problem and a solution. Here, the issue is real. It's tangible. The tires that are not being recycled to the utmost efficiency. We need further partners to get to the final product in a profitable way. And that's what we're looking for here. But we have the technology, we have the team. Not only that, their rewards, I feel, are definitely high enough to mitigate any risk. Besides, as everyone has spoken today to the environmental benefits, which clearly there are many, but within that, we're literally creating an economy. We're creating an American business without creating American jobs. A process that has not really been done before in the way we're doing it is going to be creating a whole new business and businesses within the business. So it's a really exciting opportunity. And not only that, when it comes to the costs of doing our business, it's much less than other industries. And even within this industry, due to the nature of the product and the nature of the raw materials, which are abundant, the tires, we have, relatively speaking, low costs. So for me, this was a very obvious and unbelievable opportunity. And I definitely invite those who want to partner up with us to come on board and get part of this exciting new development. Thank you.
Mendel.
Thank you, Shoshana. And thank you, everyone, all the tremendous presenters. Just like to make a few closing remarks before I welcome your questions. And I am tremendously excited about the future for smart tire recycling, particularly our joint ventures. There are some joint ventures that will be announced over the coming months, but we're announcing now our joint venture with the University of Pittsburgh on and besides the potential of the ash content removal and increasing the value of our current business plan, one of the interesting advantages of this work, this joint venture with the University of Pittsburgh, is the potential to cut our timeline to profitability at the University of Pittsburgh of refining carbon black. We can take existing technologies and increase the revenue of their outputs. So that's something that I think is interesting for investors to note. I recently got some exciting news in the last week or so. Our IP attorneys had made me aware that our patent that was published in 2019 is actually has been issued and is being sent to Smart Tire Recycling as we speak. That's very exciting for our Robert Enoch has described the basic reactor, which I'm not an inventor, but I invented a word. I invented a word to describe the technology called unbaking. It's not in the dictionary, but I think it describes for simple people like me what's taking place in this technology, where imagine a loaf of bread. You have oil, water, butter, and eggs, and flour, and the bread's baked in a way where you don't want it to fall apart. Tires are baked in a way where they make it very hard to fall apart because you want to drive safely. So this unique technology breaks down the components cleanly in place. And part of our technology, part of our unique technology, is a very interesting way to separate the materials and gain the most value of each of the components, each of the oils, and so on and so forth. As you heard about the oils, there's many unique aspects to our oil, and we're very excited about that. We bring our oil into some laboratories, and people envy the oil of Smart Tire Recycling, and we're only improving on it. Why did I put up a list over here of corporations? So the first question that smart investors ask me, and we have a lot of smart investors here, is what is the biggest risk? One of the primary answers is, yes, you have a technology that works. It's all nice and fine, but can you take it to the end game where I'm going to make profit, which takes a lot of capital? So what's very interesting about what we're doing at Smart Tire Recycling is that the products that we're producing and the problems that we're solving are extremely compelling and interesting to a very long list of multi-billion-dollar corporations that have been reaching out to us, and we're engaged in high-level conversations. The $1.3 million we last 18 months to perfect our technology, and it is what got us to the point where we can have these high-level conversations with these potential institutional investors and partners on a strategic level. The window for angel investors to come in and take a piece of this cake is closing. Our technology has come a long way over the last 6 months, and we are engaging in high-level conversations with companies that want to put in $30 million to take us all the way to the end. So there is a small window of opportunity to help us put the finishing touches on what we're doing to be ready for the institutional investors, and that's where you come in. The StartEngine campaign that we started a few months ago, we're close to $500,000. We're raising $4 million to build our pilot plant over the next 18 months. And experts have estimated that the valuation of the company will increase significantly from where we are today post-pilot plant. So I encourage you, if you have an interest in investing, to take advantage of the opportunity now versus later. And you can go to startengine.com/SmartTire and make the investments there. And I welcome your questions. Thank you.
Mendel, can I ask a question?
I'm sorry. I was on mute. The question, we have been having some questions coming in through the chat throughout the presentation. You can continue to post them there. I'm gonna pose them to our presenters. And what do they say? So the first one we have is from Steve, wanting to know, how does your production of carbon black differentiate itself from other carbon blacks, like even virgin carbon black?
Thank you, Steve. So as was mentioned, I'll first talk about virgin carbon black, kind of big picture, and this is an interesting component. So our carbon black is essentially, the goal of our process is to retain the original carbon black. And our carbon black, as it's grade, we have people that have worked for major tire manufacturers over the last couple of decades on our team. The grade of carbon black we're producing as of today can be sold directly to tire manufacturers. And the more ash content we remove, the more of it we can sell to tire manufacturers. Some of our competitors, and we're the success of all our competitors helps each other because we're a very small team, and we're in the wild west of it. I bless all of our competitors to be extremely successful because there are so many tires to take care of, and we need all the help we can get. But what's unique about Smart Tire Recycling's technology is that some of our competitors that use batch systems, their carbon black can't actually be sold directly to carbon black manufacturers, which is the biggest two tire manufacturers, which they are the largest buyer of carbon black. Ours can, and as we improve in the grade of our carbon black, the more of it we can sell to carbon black manufacturers, to tire manufacturers. In terms of carbon black manufacturers, companies are actually buying recovered carbon black at a premium. It's in a high demand. Carbon black manufacturers, and this point hasn't been emphasized enough, are from the highest emitters of CO2 emissions in the world. And they are being forced to spend tremendous resources to lower their emissions. When I talk dirty, I'm from Pittsburgh. I don't remember this, but what I heard is 40 years ago in Pittsburgh, you walked outside, your white shirt became dirty. I'm talking dirty manufacturing. And over the last 15 years, all the small to medium carbon black manufacturers have closed down because it's just a dirty business. They haven't found a better substitute for carbon black in tires. If the 1 billion tires that are recycled, if the 1 billion tires that are currently thrown away each year are recycled using technologies similar to ours, we can offset the need for virgin carbon black by over 40%. Shoshana?
Okay, great. Sorry. Okay, this one came in from Miguel. He wants to know why hasn't Smart Tire Recycling made some big deals, partnerships, and other business agreements with big companies, counties, and even countries? I think along those lines, how will you be able to raise the capital that you need? It doesn't seem that it's going to happen on just this crowdfunding round.
Thank you, Miguel. Thank you very much for that question. The Smart Tire Recycling is in a unique position, and the way we differentiate ourselves from many of the other players in the industry is that, as was mentioned, I have gathered together almost all of the major players that have attempted to commercialize these technologies in pyrolysis and tire recycling over the last close to 15 years. And we have sat down and figured out all the mistakes that have been made, and we're kind of going under the hood and really redoing everything from scratch. So we're taking a long, short approach, and we're getting it right. And we were blessed by God that we've now been successful in proving our technology, and we're ready to scale. And because we're at this point of success in production, and of many companies have scaled too quickly, we've taken the approach to go to scale in, step by step, milestone by milestone, and not skip any steps. And we're carefully listening to all the advice of all those that have come before us. And that's where we differentiate ourselves. And the person that's going to figure this out, which we think we're going to be one of the major players, the capital that's coming to our door is very large. And we're in high conversations with companies that can write checks to take us through the next 10 years and a day. We're solving multi-billion-dollar problems, and we have a profitable solution. The companies that are going to be involved in this will have the resources to go all the way through. Shoshana?
Mendel, can I jump in for a second?
Sure.
I just want to add that when Mendel says that we corrected mistakes, he's referring to mistakes of other companies, not our own. That there have been a lot of companies that have tried to work on these issues of tire recycling, obviously in a different way. And there were a lot of engineering mistakes made along the ways. To answer your question about, why don't we go directly to the big companies? That's just more of a political issue, that they want to see a certain amount of funds raised or certain milestones reached first. And we are fulfilling those and have fulfilled them, and are on track to get some of those big contracts. But we're opening up to get to the final stages. We still would like more partnerships. Thank you.
Thank you, Adam.
Thank you. This next one is from Harry, and it might be directed at Bruce and Mendel. What is the composition of the resulting oily solvent, and how is the process, heat, and pressure created for this system?
Dr. Enoch and Bruce, if you'd like to chime in on that question, you're welcome to.
I'm going to defer to Dr. Enoch because he's the genius of the method.
Okay.
And Dr. Schulte, you can comment as well at the end.
Well, with respect to pressure, that's the easier part to understand. If you remember from the diagram, the pressure will be supplied by pumps, typical commercial pumps. The water pumping is straightforward. You're probably familiar with water pumps. And typically when you want to generate a high temperature and high pressure fluid such as water, you accomplish the pressure change first because it's relatively easy to pump a liquid compared to compressing a hot gas. So for the water and the propane, we would just use commercial pumps, both on the lab scale and on the large commercial scale. For the temperature increase for the lab scale, I believe that's we use electrical heaters are very common. I know in my lab and in the facilities that we could use electrical line heaters to generate the elevated temperatures that we need for the process. For a larger scale, we consider the same kind of high temperature sources used in commercial plants. You know, so you might have to, if you're not able to purchase a heating utility, you might have to generate your own on site, burning of fuel in order to generate heat, transferring that heat to the water or the propane in a heat exchanger. So I think the general answer is that the pressure and temperature would be supplied in the same type of method as in most chemical and petroleum plants. There would even be a chance if there were very light components, and there are knobs to control the oily solvent. If there were very volatile components, you could even use some of those volatile components as the fuel to supply a part or most of the heat required for the process.
Thank you. Q, do you have anything to add to that?
I'll just add one more thing. Probably the more difficult thing to do, but there are commercial pumps and extruders available for it. Is pressurizing the tire crumbs, right? It's not difficult to imagine. It's more difficult to pressurize solids through a pump than liquids. So that's one reason it's nice to get the solid materials in a small form. And there are in the polymer industry different types of pumps and extrusion apparatuses that are designed to push very viscous materials at high pressure. So fortunately, all of those pressure and temperature changing devices are commercially available and used in other industries.
I just like to add one point. Thank you, Dr. And Dr. Schulte, would you like to mention something?
No, that's fine.
Okay, I see you unmuted. Okay, so I would just like to, on the topic of the oil, so we are very encouraged by the letter of intent that Bruce's team has signed and committed to, and the kind of on the technology development side of comparing pyrolysis to what we're referring to as tire digestion, which is like a cousin technology. So one of the unique aspects of this supercritical fluid technology is a bit of a newer developing technology, and the room for improvements and the developments that are taking place are every 6 months, the technology improves like 3 or 4 times. And we have experts on our team that have expertise in these technologies. Some of the pyrolysis technologies have been around for 60 years and they haven't really evolved much. So we're dealing with a up and coming technology, and we have something that works for what we're doing. And we're planning to commercialize that, but we also have an R&D side of the company to continue to perfect and improve our end products to really continue adding value. Shoshana?
Okay, thank you. This question is from Robert. Do you have an estimate of the capital required to establish a single plant at economic scale? And what are your estimates of the payback period for that investment with recovered carbon black, 15 to 20% ash content?
I didn't hear the last sentence.
I'm sorry. And what are your estimates of the payback period for that investment with recovered carbon black with 15 to 20% ash content?
Thank you for that question. We're raising $4 million to build our pilot plant. Our first small commercial facility, which we intend to be operational in the next 36 months, will cost about $15 million to scale and will be profitable. The return on investment is estimated at about 5 years, but I can send you the detailed financial analysis from our CFO that has a lot of work on the details, and I'd be glad to share that information with you, Robert.
Thank you. This question is from Franklin for, I believe, Dr. Enoch. Which size is required for the tire crumb, which is fed into the reactor, and have you already achieved a 10 to 20% ash content? How would you reduce the ash content from the recovered carbon black?
So the answer to the last question is yes. I've been working with Smart Tire Recycling for many months already, and I've been receiving samples, each of which has an ash content measurement. And I have a little Excel spreadsheet, but I don't have it in front of me, but I can tell you that almost every number is slightly above 10 and usually below 15. So 12, 13, 14, 16, 15, numbers like that in every single sample that I've received so far. Another question was the size of the crumb. What we're doing right now, the size that we've received, I'm trying to remember the exact, I'm just going to give you a ballpark number. Mendel?
30 mesh, 30 mesh.
There, okay. All right, thank you for that. So
30 mesh, but that's because we have a small machine, but we can go bigger than that.
Right.
We can probably use a 1-inch piece.
And I think one of the other questions there, which I'm going to, as you might understand, defer a little bit on, is how are we trying to get the ash out? We have in our agreement, we are going to actually be assessing 5 different methods and seeing which one is the least expensive. And I can tell you that I'm quite aware of every single attempt ever made to address this problem. We've looked at them. I know their strengths and weaknesses, and with that background, we've developed 5 what I think are really clever methods, several of which involve no chemicals. So those are the most exciting. I'm going to have to not tell you the details of those for now. And but I guess I want to make the point that the first thing I did was take about 6 weeks, and I looked into absolutely literally every single attempt to do this that's ever been made. And with that database, we've moved forward on several fronts, and we're actually going to try a few techniques that no one, to my knowledge, has ever even thought of. So, Mendel, I believe that's the level of description that you wanted me to give.
Okay, Shoshana.
Okay, this next one is from David. In your opinion, would the ideal situation be to sell Smart Tire Recycling and its patented processes to major corporations, or to take it to the next level, at which point the Smart Tire investors would benefit from this sale, but then be out of the picture for any future personal profitability?
Thank you, David, for that important question. And I can tell you my personal preferences, but obviously as the company grows, we're open to ideas and we're open to strategic thinking. We want to get this right, and it doesn't have to have our name all over it. We want to do what's the most efficient for everyone involved. Personally, at this point, there's room for 100 plants just in the United States alone, with $12 to $15 million of revenue from each plant in the United States alone. Our patent actually goes in Europe and other countries. I think the potential is so large and so great that if we can get plants financed and have a part of this, we would like to continue growing the technology and not have a full sellout. I think our next this round of funding and the next will probably come from investors. But I think once we reach that point of development, especially with the team we have in finance and strategic growth, we can get a lot of that financed for further growth. So that would be the direction that I would encourage the team to go. But we're definitely open to suggestions from others. Thank you. Shoshana?
Yeah, thank you. Okay, I think we have time for maybe about 2 more questions, and then we'll wrap up. So this one is from Brent, and he wants to know, how is this process different from thermal depolymerization?
Dr. Enoch and Dr. Q, would you like to comment on that?
I'll take a first stab at that, if that's okay. Shoshana, if you wouldn't mind while I'm answering this, could you flip back to my middle slide? I think that will help me answer the question and help everyone. That one right there. Thank you. So what you may not know about this, the other method is just thermal depolymerization. You're heating things up and you're adding so much energy, you're literally almost just shaking the molecules apart, if you want to think of it in that way. So what's a little bit different in this one, but it's a big important difference, is that if you think about it, right, it's hard to transfer heat to small rubbery particles. They're particles, they may not be touching really intimately and closely. So one thing that the water does is that it allows you to very efficiently apply the heat to and throughout the particle. So that's one huge difference. And that's one thing that allows you to do this at a lower temperature and more quickly. Another thing, and this is probably the most non-intuitive thing that is surprising to find out, most of us know that water is very good at dissolving polar things like salt or sugar, right? You know, you could dissolve sugar in your coffee, dissolve salt, and most of us have learned this phrase all of our lives, that water and oil don't mix. Well, what's really remarkable is that when you take water above what's called its critical temperature, and that's the temperature when you no longer can have a liquid and a vapor phase together. It's just one fluid phase. That water actually becomes nonpolar. It actually becomes an excellent solvent for hydrocarbons and a very poor solvent for polar materials. So that's exploited in this process. Not only can the water apply heat, but the water can also become very miscible and dissolve the oily solvent components and carry them away. And the last thing that is very sort of fortuitous and special is that if you add some oxygen, which is what we're doing, the oxygen mixes with the supercritical water and with the hydrocarbon molecules. And one of the tricks is that you add just enough oxygen. You don't want to burn everything, right? That would defeat the whole purpose. But if you add a little bit of oxygen, that oxygen can react with some of these long molecules. And in essence, it's a chemical way to snip them into smaller ones. So I think that encapsulates, those are some really profound differences between pyrolysis. And what's the price you pay? You know, you have to pay a little bit of a price, right? You're adding water, and you could also add propane. Propane is a very good solvent for the hydrocarbons too, and it'll stay that way even when you condense and cool the water. So what you have downstream, you see those 3 vessels, you have to have a little bit more of a complicated, it doesn't mean that it's expensive or prohibitive, but it is a little bit more complicated separation scheme, right? Because you want to get the carbon black particles, you want to condense your water and reuse it. And if you use the propane, you want to condense the propane and reuse it when you recover your solvent. So I know that was a big nutshell, but in a nutshell, that's the fundamental differences.
Thank you, Dr. Enoch. Shoshana, do you want to do one more question, or you want to close?
I actually think we're out of time.
Okay.
But I want to thank everyone who took the time to join us today. I know that we didn't get to a lot of the questions. We are hoping we will respond to them and get back to you via email. You can continue to send questions to Shoshana at smarttirerecycling.com. And make sure to invest with us if you're interested at startengine.com/smarttire. And anyone who registered for today's webinar will be receiving a recording of it over the next couple of days. Thank you, everyone.
I can stay on for a few more minutes if someone wants to ask me a specific question.
Mendel.
Hi, Lawrence.
Okay. At least I'll get one question and one answer. Did you do a budgetary cost for implementing your ash reduction techniques to other manufacturers of recovered carbon black?
Not yet.
Not yet.
We're not yet at that point. If you could send us some of your samples, we'd be able to probably answer that question.
You've got 5 samples coming shortly.
I look
Okay, cool.
forward to that. Thank you.
Great presentation. Thank you.
Thank you.
Talk to you later.
Mendel, this is Robert.
Hi. Hi.
Can you hear me?
I can, yes.
Okay. My quick question is, raising the 4 million for the pilot plant, what is the capacity of the pilot plant then? What are you expecting?
So we're looking at a couple different options, but I say it's in the range of about 250 to 500 tires per day in terms of processing.
Mm-hmm. Okay. And when you
the details of the output we have, but the goal would be to prove our concept on a commercial scale.
Sure.
Many of our competitors have scaled large systems. We want to run this thing around the clock for a couple months and really prove its ability to accurately produce and get this right. And that's kind of, and to produce commercial size samples for the strategic investors that we're in conversations with.
Okay. Good. Yeah, no, good luck. Looks interesting.
Thank you. Okay, any further questions? Hearing none. Thank you everyone for joining, and have a great day. Thank you, Robert. Thank you, Q. Thank you, everyone. Great job.
Thank you. Thank you, Shoshana, for all the work you did.
Thanks.